Hi, my name is Jan Brugard, and today I will present new features from SystemModeler 5. Everything from how you can interact with other software to how the tool has become more flexible for different use scenarios. Okay, let's get started. My name is Jan Brugard. I'm going to talk about the latest release of SystemModeler, which was released, I think, around June, if I remember correctly, this year. And I'll show some of the new features, and of course not all of them, but give an idea of what we added. But before I do that, I'll start with this slide, which of course should change, I think, the style sheet here for these conferences. It's a bit small, but I just wanted to talk a little bit about what we aim to with SystemModeler. So it's a system modeling tool, as the name says, and the idea is to have something that isn't only modeling and simulation, but it all actually takes you the whole way with analysis also and design work. And that's where it combines with Wolfram language. And that's actually something you'll see in 5, that we have integrated more with the Wolfram language than we've done before. And we are presenting the software in another way. We're actually not really distinguishing whether you have Mathematica 2 or not. We're looking at the tasks. And some tasks might require the combination of Wolfram, or Mathematica and SystemModeler. Others might be purely Mathematica or purely SystemModeler. We're not really caring about that. We're looking what is it you want to accomplish and presenting it that way instead. And yes, as the Wolfram language, it has a holistic approach. So we try to have something where things work together, where you work with one area and have some reason for combining it with another. It should just work. And all of that is to make it a very accessible tool that you can use in. If we look at in education, you should be able to use it in almost any class in an engineering program. And if we look at industry, of course, in many different applications. Tomorrow I will have a couple of examples of real-life scenarios. So, top key features. First, we have something called FMI, Functional Mockup Interface. I'm not going to showcase that because it's kind of not very easy to show in this kind of environment. But what it is a method of exporting your models in so-called functional mockup units that can be used in other programs, or take functional mockup units from other programs and use them in SystemModeler. So for instance, you might have some legacy code from some other software, might be, let's say, competitor like Simulink, and you want to move to SystemModeler, then you can export that code into an FMU, import it to SystemModeler, and use it from within the tool. And this integrates with a wide range of tools, like at least 30, probably more. And more tools are adding that support, so it's a great way to interact. We added support for new components. I will go back to that a bit more later, so I'll not talk about it now. We also added more ready-made models, which I also will illustrate a bit more in a bit. We updated diagrams, so they should be easier to read, easier to understand, look more. So the icons you're seeing should be easier to relate to the real world kind of correspondence. We made it easier to configure models, and this is something I will illustrate soon. I will do that with an example of a car where we will switch wheels in a kind of nifty way. We improved package handling, meaning that if you are working on larger projects, you might be collaborating with several different people, and you want to change the structure of how you store things. Let's say you have stored everything in a single file to begin with. The project expands, and you want to have it work together with another colleague. Then you might not want to work on the very same file. Then there is easy now to actually split into different levels the files so you can work on your separate files. And of course, you can use them in your whatever you're using, Git, SVN, CVS, and so on. The next parametric simulation I will show is actually a bigger topic than just parametric simulation, but that was what kind of fit into the graphics. But I'll get back to that. We have tried to make it easier to get started. Several different things came into that. For instance, the updates of the icons, but also making different use modes. So you have modes in SystemModeler that are where you're not exposed to all the different menus and so on that are available. So you kind of clean up so you get the basics parts and get a quicker start. Also added better examples and so on. And finally, which we have with every release, better performance. So I will wrap up with that. OK. So let's look at this first. As I said, we have added support for new model libraries. And that's kind of the core of SystemModeler, to have a lot of components that you can use to build up new models. In this case, the biggest new library, or most important new library, was media. We also added noise library and added a bunch of components in other libraries. But I will talk a bit more about media and why that is interesting. So the media library, what it has is basically a bunch of media properties for different type of gases. And it makes it possible to model something. Here's a very simple example of where we are trying to look at the stresses caused from an expanding gas in a vessel. Let's look at that model. OK. To open up the help. So yeah, we can actually, doesn't want to let me zoom for, yeah, there you go. So the help will describe a bit what you can do with example and so on. And that's actually one of the things we worked quite a lot with, to make each example better documented, so it's easier to actually replicate and do your own. But let's then check at this particular example. OK, so here's the example. We have our container down here. The container is connected through some sort of wall here that has some conductance where we might lose energy, or transport energy in any direction, of course. And we have the sun that gives sunlight. And now in this model, we have pulled data from Wolfram Alpha to get the temperature in Linköping for a day this spring. And we have imagined this is a 1 cubic meter kind of container that we have put outdoors. And we want to see how this gas expands. So if I simulate this now, oh, there was another simulation ready since my preparation. We'll actually get back to that. OK. So what did I do? Oh, OK, sorry. There you go. So we simulate here. It's perhaps not that easy to see. There you go. So here we have two boundaries. The upper limit is where we will have, where for sure this vessel will explode or something like that. And then the lower one is where we should have a warning, which means that right now this kind of works, and we're seeing kind of the stress we have inside the container. I mean the pressure in the container. Now what we can do with the media library, so this is using one specific gas. So if I click here, I can see it's very small, but I have a list here, and it says, I'll read it for you. It says that it's an ideal gas of H2 from NASA Glenn coefficients. So it's like the official NASA tables for this gas. And then there are a bunch of different gases to choose from that kind of fits this scenario. So I could choose some other gas, like moist air in this case, and see whatever happens when I use that instead. I actually have no real idea what happened. OK, division by 0, that was not good. So air was probably, which means that it probably says that it kind of exploded. So yeah, so you change gases, and we'll see what kind of happens when you do that. So for instance, if you want to model a refrigerator, this might be something that is of interest, or a compressor of some kind. If afterwards you want to see more about the examples for each of these, I have actually put links here that you can follow to get examples online that you can also download afterwards. Okay, so I haven't changed the title here, sorry. So this is not the right, let's remove the title. So continuing on this of kind of configuring your models, I'll do an example of a car. So let's say configure a model, something like that. Was that spelled kind of correctly, at least? And what I'll do, I'll open this in SystemModeler. And we get this model here. We can see that it's just a drive line of a car. So in the middle, we have a powertrain, and then we have 4 different wheels. And just as in the media example, we have drop-downs list here. So we can change the type of powertrain we have. So we've chosen to have 2 different levels of source of powertrains that we can choose from. But we can also change which type of tires we have. In this case, we can use summer tire on asphalt, summer tire on gravel, summer tire on ice. So let's try summer tire on ice. And I don't know if you noticed, but these icons here changed because we changed tires. So let's do that again. And we changed to summer tire on gravel. And they changed. But of course, it's not only the icon that changed, the equations behind the scenes changed also. So now if I simulate this, we will simulate the scenario of this car driving on gravel with these summer tires. I actually tried that with my bike the other day when going out here. For some reason, you have a tendency to like to have gravel in every single crossing. The rest is just perfect, but in crossing, you like gravel here. What's up with that? It's just dangerous. Okay, so this is how this simulation looks like. It might not be that easy to see what's happening. What we're doing, we're plotting the 4 different wheels and how they're moving, so we can kind of realize it's doing turning around here, and we can look at, okay, this was some other simulation, I think, where it was actually sliding a bit more, so we do the new. And it's easier for us to actually see where it's, oh, sorry. Yeah, so we see it's kind of sliding through the corners in the gravel. So it kind of loses a little grip, gets the grip again, and so on. So this ability to build models that are reconfigurable makes it much easier for you to develop a model that you can then send to somebody who can play around and test different scenarios easily. Yet again, this is available on the website, so I'll just show how it looks like when you're on the website. Let's do that. So you have the full model, some examples, and you can actually download it to try it afterwards to kind of get the idea of how it works. Okay. So it was titled here, an example of Hair links. I used that before, but not. It was more complicated back then. So I think I had the title Parametric Optimization on the first slide. But what it is actually we can do a parametric simulation. And this is so this allows us to use the results in different sorts of ways, like for instance, for optimization. So let's look at an example of that using the classical Hair links scenario for it. So if I start by opening that model here in Mathematica, it hopefully open here, yeah. So it's kind of dull-looking model, but we have some sort of representation for the hair and the links, and then these are interacting. Well, the lynxes are eating hairs if that's interaction. And let's look at what we can do with that if we look at the notebook here and zoom in a bit. Is that readable? Should we make it like that. Okay. So I'm not going to get through the entire example here, but I'll show. So the function is this one. WSM parametric simulate value. There are several functions, but this is one of them. Parametric simulate value. So what it does, it takes a model, and we tell the model that we want to get the result for the number of hairs and the number of lynxes, and we want to vary these 4 parameters, which is the initial population of each of those species, as well as the birth rate factor of each of the species. So let's simulate that. Once we simulate it, we will store that in this sim file here. And we can query that now, saying that we want 150,000 hairs to begin with, 25,000 lynxes, and the birth rate for them is also set here. And then we get 2 interpolating functions as a result for these 2, and we can, of course, plot these. And in this case, we only plot the second, which is the number of lynxes, I think, but we could, of course, plot both of them, and we'll see the result. Okay, so this is nice. We get the result, and we can plot them against each other and so on. But the important thing with this is that now we can use this to create small programs, for instance, for optimization. But in this case, we'll use it more for making an interactive interface, a snappy manipulate that will show us, let's see, does it fit? Kind of. Yeah, so let's do that like that. So we have here a manipulate that uses this simulation, and we can set the number, the birth rates up there. And what we see is the number of hairs and lynxes at any given point in time. This is the initial value, so I can change that. So let's say this is the initial balance, and we will get the kind of circle of life for these 2 species. Or we change the birth rate of any of them and see how that affects the population. So these kind of functionality where it makes it easier to use together with mathematics and get snappy, good results. So performance. As I said, we have increased performance, and that kind of takes us back to the first thing we talked about, media models. Media models are typically quite demanding when it comes to computational power. So if we look at this diagram here, we can see examples of some of the medias. Actually, with our previous version of SystemModeler, we could load parts of this media library, so we've done that. So the four first one did work, but we can see the red showing how much time it took to simulate those. And the 2 last ones weren't possible to simulate with 4.3. So meaning that it's 2.7 to kind of infinity times faster to simulate today. So these kind of data-heavy simulations have become much faster. So if you're doing anything of that, this is a big benefit of the new release. Then, as I said, we have added a lot of built-in examples. We have all examples that are downloadable. They're actually also built in today, or almost all of them. Every example that doesn't require an additional library is built in. And also more documented, have stored plots and so on. And we also made it possible to access them easily from within the Wolfram language. So we can run a command, WSM examples. And this will give us, now this takes some time on mine because it analyzes all the libraries I have, and I happen to have quite a lot of libraries. So if you only have the standard, what did that become black? Who knows? Okay, typically it doesn't look black like that. But anyways, we have the different packages that might contain an example. So I could, for instance, dig down to, let's say I take biochemistry here, click on that, and it will tell me within this examples package, you have some example to run. So I click that. And there we have 8 different examples that look very boring. I think I opened Yeah, actually here, this is kind of interesting. The other example here, this. Circadian oscillator. Does anybody know why this is interesting? Read about the Nobel Prize in medicine afterwards, and you will know why. Yeah. So it was actually the one that kind of research around that gave the Nobel Prize in medicine this year. So this way you can kind of access them. Let's take the example we just looked at before, or I take some other industry examples. I'll take some by random here. Heavy equipment, active damping. I can then kind of click on it, simulate it directly. I will get the results from within here without having to know anything about it. I can access the documentation and so on. So it makes it easy to explore and find things, especially when you don't have this black background that kind of came here for presentation reasons. Okay, so that's a quick overview of some of the new features. But basically, one could say that we have improved it like in every kind of aspect. There has been improvements from usability to performance. We have a couple of presentations coming up still. So after this one today, there's one on the Wolfram language integration, and that one is actually looking into the future. So you will see, will get a taste of what's happening next, and it's pretty cool, at least if you ask Roger. And then tomorrow I will present 3 different examples from industry, and they are pretty cool if you ask me. There's one example for how you use it to analyze liver function in order to get better liver treatment. 5% of Americans have liver disease, by the way. So it's kind of an important thing, and you can't really analyze liver function today. There's one on how to do helicopter landing autonomously on a ship, and there's one on producing clean energy using Stirling engines. So those 3 examples I'll show, so they're from different customers of ours. And then there will be one that I don't know anything about because I have not been involved. So I will go to that and see. It's reinforcement learning with SystemModeler. Sounds interesting. And then down at the basement, there's a hardware lab where you can try out and see how you can use model-based design to play around and understand more of a system. And you can actually, what we have there, you get the link to download the material so you can play around with it at home. So with that, I'll thank you very much.